Hello, ladies and gentlemen. I am Ahaan Damle, and this is my project for Raman Award Stage 2, the topic for which is the parallelogram law of vector addition. My model consists of a piece of cardboard resting on a fulcrum and 7 nuts, each of uniform weight. Here, I have placed two sets of 3 nuts each at points A and B, both of which are at a distance of 3 centimeters from the fulcrum. The fulcrum is marked by point O. Now, the challenge is to balance this piece of cardboard by placing just one more nut on it. Seems impossible, doesn't it? We know that in order to bring a lever to equilibrium, the net torque on it must be zero. But in this case, there are two torques being applied to this cardboard, both of which must be counteracted with just one more torque. To, to perform this, we can calculate the resultant torque due to both these sets of nuts using the parallelogram law of vector addition and place this nut in such a manner that it balances the resultant torque. The parallelogram law of vector addition states that if two vectors act along the adjacent sides of a parallelogram, then the resultant vector is along the diagonal of the parallelogram from the point of contact of the two vectors. To complete the challenge, let us assume that the weight of each of these nuts is 1 unit. So, the torque due to the set of nuts on point A is 3 multiplied by 3, which is 9 units along OA. Similarly, the torque due to the set of nuts on point B is 9 units along OB. So, I have constructed segments OP and OQ both equal to 9 centimeters. To complete the parallelogram, I have constructed segment QR equal to OP and segment PR equal to OQ. The diagonal OR gives the resultant torque. Therefore, this nut must be placed in such a manner that it is at a distance equal to OR from the fulcrum, but in the opposite direction. This point is marked by point X. So, when I place this nut at point X, the cardboard should get balanced. This experiment can also be performed by varying the number of nuts and their distances from the fulcrum. Here, I have kept 3 nuts at point A and 2 at point B. The distance OA and OB are both 3 centimeters. Again, if I place this nut at point X, the uh, the torque due to this nut balances the resultant torque due to both these sets of nuts, and the cardboard gets balanced. Here I have placed 4 nuts at point A and 2 nuts at point B. The distance OA is 2 centimeters and OB is 3 centimeters. When I place this nut at point X, the cardboard should get balanced. In conclusion, we saw 3 examples where we calculated the resultant torque due to two sets of nuts using the parallelogram law of vector addition and placed another nut in order to balance the cardboard. Thank you.